The ceaseless human inquiry into the nature of consciousness and its potential interaction with the physical substrate of the universe inevitably leads to one of the most provocative and boundary-pushing questions in modern physics and philosophy: can consciousness exert an influence upon matter at speeds exceeding that of light? This query stands at the very precipice where established relativistic mechanics, anchored by Albert Einstein's profound declaration that nothing with mass can attain or surpass the velocity of light, confronts the often elusive, sometimes mathematically elegant, yet experimentally frustrating domain of quantum non-locality and the very mechanism by which subjective experience arises from objective electrochemical processes. To explore this possibility, one must first meticulously deconstruct the components of the question itself, defining consciousness, understanding the constraints imposed by special relativity, and critically examining the known phenomena, both classical and quantum, that hint at possible, albeit currently unproven, faster-than-light, or superluminal, interactions. The established cosmological speed limit, the cosmic speed constant, is not merely an arbitrary barrier. It is a fundamental consequence of the structure of spacetime as described by the Lorentz transformations, the mathematical bedrock of special relativity. This theory posits that the speed of light in a vacuum is invariant for all inertial observers, a principle experimentally verified countless times, most recently with exquisite precision in observations involving high-energy cosmic rays and the synchronization of atomic clocks across vast distances, such as those utilized in the global positioning system, where even minute relativistic corrections must be applied to maintain nanosecond accuracy. If information, or causal influence, were to travel faster than c, the principle of causality itself would be jeopardized. In one frame of reference, an effect could precede its cause, leading to logical paradoxes that undermine the very coherence of physical reality as currently understood. However, the allure of superluminal influence stems largely from the perplexing realm of quantum mechanics, specifically the phenomenon known as quantum entanglement. Entangled particles, often created through processes like spontaneous parametric downconversion, share a single quantum state regardless of the spatial separation between them. When a measurement is performed on one particle, instantaneously collapsing its wave function, the corresponding state of the distant partner particle is determined immediately. A correlation observed in experiments spanning thousands of kilometers, as demonstrated in pioneering work utilizing satellite links between ground stations, such as those conducted by the Chinese MISHAS satellite project. Einstein famously dubbed this spooky action at a distance, precisely because the correlation appears instantaneous, seemingly defying the light speed limit. Yet, decades of meticulous experimentation, including rigorous loophole-free Bell tests, which eliminate the possibilities of local hidden variables, have confirmed the reality of this non-local correlation. Crucially, despite the instantaneous correlation, entanglement cannot be used to transmit classical information faster than light. The outcome of any single measurement is inherently probabilistic and random according to the Born rule, meaning the observer at one end cannot predetermine the result to encode a message. While the collapse is instantaneous, the information about the specific collapsed state must still be conveyed via classical, light-speed limited channels to confirm the correlation. This is the no-communication theorem in full effect, a robust mathematical and experimental barrier preventing superluminal signaling via standard quantum mechanics. This is where the discussion pivots from established physics to the highly speculative territory where consciousness might insert itself. If standard quantum mechanical interactions are bound by the speed of light for causal signaling, could the non-physical aspect, the subjective experience, consciousness, somehow bypass these constraints? The scientific community remains deeply divided on the very ontology of consciousness. Materialist or physicalist perspectives, the dominant paradigm in neuroscience, maintain that consciousness is an emergent property entirely reducible to, or supervenient upon, the complex electrochemical signaling networks within the brain, particularly involving neuronal firing, synaptic plasticity, and potentially, as suggested by theories like the integrated information theory, or IIT, The structure of informational integration, $phi. If consciousness is strictly a physical process operating within the spacetime geometry described by general relativity, then any influence it exerts must also obey the universal speed limit c. Conversely, dualistic or more radical interpretations suggest consciousness might inhabit a realm partially or wholly independent of the purely physical substrate. If consciousness is more fundamental than spacetime itself, perhaps serving as the underlying reality from which spacetime and quantum fields emerge, a stance sometimes explored in panpsychist or certain interpretations of quantum consciousness theories, such as the Ochoa model proposed by Stuart Hameroff and Roger Penrose, which posits that consciousness arises from orchestrated, objective reduction of quantum states within neuronal microtubules, then its potential influence mechanism might operate outside the constraints that govern particle interactions. The Ochoa theory, for instance, speculates on quantum coherence within the microtubule lattices of neurons, suggesting that the collapse of the wave function, the objective reduction, is a non-computable physical process linked to spacetime geometry fluctuations, potentially involving gravity at the Planck scale. If the observer effect in quantum mechanics, the notion that the act of conscious observation precipitates wave function collapse, is indeed fundamental and not merely a result of the classical measurement apparatus interacting with the quantum system, then the mechanism of observation itself becomes the crucial interface. Some interpretations of the measurement problem, such as the Copenhagen interpretation, highlight the role of the observer, leading to philosophical conundrums about where the quantum to classical boundary lies. If consciousness resides on the classical side of this boundary, its interaction with the quantum system could potentially be non-local in ways not prohibited by the no-communication theorem, because the information being transferred might not be classical bits but rather a fundamental shift in ontological state. To even entertain the idea of superluminal conscious influence, one must hypothesize a mechanism. One avenue involves revisiting the notion of non-local correlations beyond standard quantum mechanics. Could consciousness exploit subtle, yet undetected, loopholes in the constraints imposed by causality? Theoretical physics offers several mathematical constructs that permit superluminal propagation, though none have verifiable experimental support, and most violate known conservation laws if information is transmitted. These include hypothetical particles called tachyons, which are mathematically defined as always traveling faster than light, possessing imaginary mass, and whose energy decreases as their speed increases, approaching infinity as they slow to see. However, the existence of tachyons would inevitably lead to causal paradoxes, and exhaustive searches in high-energy particle accelerators have yielded no evidence for them. Another theoretical recourse lies in exploring the topology of spacetime itself, specifically through potential shortcuts like traversable wormholes or Alcubierre drives, which manipulate spacetime geometry to achieve effective superluminal travel or communication without violating local relativistic principles within the warped region. While these solutions are mathematically valid within general relativity, they require exotic matter with negative mass-energy density, a substance whose existence remains highly speculative, despite occasional discussions surrounding the Casimir effect, which exhibits negative energy density in restricted configurations. Could consciousness, through some unknown psychophysical coupling, subtly influence the very metric of spacetime, causing momentary, localized distortions that permit faster-than-light causal paths? This ventures into the domain of psychokinesis, or mind-matter interaction, a field long marginalized by mainstream science due to a lack of rigorous, replicable evidence conforming to high scientific standards. When examining the empirical evidence often cited by proponents of strong mind-matter interaction, the results are typically either statistically weak, plagued by methodological flaws, or susceptible to alternative explanations, such as sensory leakage or observer bias. For instance, remote viewing experiments, often linked to the Stargate project conducted by the US government for decades, have yielded ambiguous results. While some anecdotal reports suggest correlations beyond chance, meta-analyses, particularly those adhering strictly to double-blind protocols, generally fail to show a statistically significant effect consistently exceeding random expectation. The crucial hurdle is demonstrating that the observed correlation is genuinely mediated by a non-local, superluminal influence originating from the conscious agent, rather than conventional, albeit subtle, sensory cues or statistical noise. Consider the field of psychoneuroimaginative, which robustly demonstrates the measurable impact of psychological states, stress, focused intention, belief, on physiological systems, such as immune response or wound healing. These effects are undeniably real, yet they operate within the confines of known biophysical signaling pathways, hormones, neurotransmitters, and the autonomic nervous system, all of which are constrained by biochemical diffusion rates and electrical propagation speeds, which are far slower than c. The gap lies between demonstrating that internal mental states affect the internal physical body, and demonstrating that an external mental state can instantaneously affect a distant physical object or system faster than light can traverse that distance. The transition from demonstrating conventional biological influence to asserting superluminal interaction requires a leap into unknown physics. If consciousness could bypass c, it would imply that the information processing capabilities of the universe are not fundamentally limited by the speed of light propagating through the space-time manifold we inhabit. This suggests consciousness might operate in a domain that is transspatial or transtemporal. One particularly intriguing, though highly theoretical, area touching upon this involves certain interpretations of quantum field theory and the concept of the vacuum. In quantum electrodynamics, the vacuum is not empty but a sea of virtual particle-antiparticle pairs constantly flickering into and out of existence. If consciousness interacts with this zero-point energy field, could it bias these fluctuations in a way that manifests a causal effect instantaneously across distance? Such a mechanism would require a deeper coupling between awareness and the fundamental fields than currently described by the Standard Model, perhaps involving mechanisms related to gravity or dark energy, the pervasive, accelerating force driving cosmic expansion, which itself remains deeply mysterious. Furthermore, the role of time needs careful interrogation in this context. Special relativity inextricably links space and time through the light cone. Events inside the light cone are causally connected, events outside are not. If a superluminal influence is exerted, the effect occurs outside the sender's forward light cone, meaning the sender could not have known the effect occurred until a light-speed signal arrives later. If consciousness is timeless or exists outside the standard arrow of time, its influence might not be bound by the directional constraint of time flow inherent in relativistic causality. However, any verifiable superluminal signal would require a measurement apparatus that can definitively register the arrival of the influence before the time calculated for a light-speed transmission, a measurement precision challenge of unimaginable difficulty. The exploration must also engage with the inherent limitations of scientific methodology when addressing subjective phenomena. Science traditionally demands reproducibility and objective measurement. Consciousness, by definition, is subjective. To prove that intention influences a distant, random physical process, say, the decay rate of a radioactive isotope or the output of a truly random number generator, TRNG, shielded from all known influences, one must show a statistically significant deviation from the null hypothesis that cannot be explained by chance, experimenter bias, or environmental factors. While some parapsychological studies have attempted this, the field struggles with the file drawer effect, the tendency for null results to remain unpublished, and the difficulty in designing experiments truly impervious to subtle, non-conscious forms of sensory leakage. For example, highly sensitive electronic equipment can sometimes pick up minute electromagnetic fluctuations correlated with the operator's state, a phenomenon that needs to be meticulously ruled out before invoking superluminal consciousness. Let us consider the implications if such an effect were definitively proven. If consciousness can indeed influence matter faster than light, it fundamentally rewrites the laws of physics, demanding a new, more encompassing theory of reality that incorporates this conscious field, or interaction modality. This would necessitate a revision of general relativity, an adjustment to quantum field theory, and a complete re-evaluation of the conservation of energy and momentum, as superluminal signaling typically implies either energy generation or absorption from the vacuum in ways inconsistent with known physics. The energy required to generate a truly instantaneous signal across cosmic distances, even one mediated by a hypothesized non-physical entity, might still manifest observable physical signatures that current detectors are missing, perhaps subtle distortions in the cosmic microwave background or anomalous gravitational perturbations. The discussion often circles back to the role of gravity. General relativity, our best theory of gravity, is fundamentally local. Gravitational influences propagate at the speed of light, as demonstrated by the observation of gravitational waves from merging black holes by LIGO and Virgo, where the arrival time of the gravitational signature precisely matched the electromagnetic signal, confirming the speed limit for spacetime curvature propagation. If consciousness can operate superluminally, it suggests it couples to reality in a way that is fundamentally non-gravitational, or perhaps utilizes a field that interacts with gravity in an entirely unknown manner that somehow evades the C constraint imposed by the metric tensor. In considering extreme theoretical models, one might entertain the possibility that consciousness relates to phenomena near singularities, like black holes, where spacetime curvature becomes extreme and relativistic predictions break down. If consciousness is intrinsically linked to the singularity, perhaps as the origin point of the wave function collapse mechanism, and singularities harbor physics beyond our current understanding, could this outside perspective allow for non-local influence? This speculation, however, remains tethered to areas where physics itself currently yields no definitive answers. Returning to the quantum realm for one final comparison, while the correlation in entanglement is instant, the causality remains fixed by C. The key difference between entanglement and hypothetical superluminal consciousness signaling lies in the information content. Entanglement transmits no usable information faster than light because the outcome is random until the classical confirmation arrives. If a conscious act could instantaneously bias the random outcome of a distant TRNG in a non-random, directed pattern, say, causing it to output more ones than zeros based on a specific focused intention, that would constitute verifiable superluminal information transfer. Decades of statistical tests on focused intention effects on TRNGs have largely failed to produce results convincing enough to withstand intense scrutiny and replication by skeptical third parties, maintaining the integrity of the no communication theorem for now. In conclusion, the assertion that consciousness can influence matter faster than the speed of light remains firmly within the realm of hypothesis, driven by philosophical curiosity about the fundamental nature of reality and the persistent enigma of subjective experience. Scientifically, the edifice of special relativity, experimentally confirmed across every observable domain, presents a formidable, perhaps insurmountable, barrier. While quantum non-locality demonstrates instantaneous correlation, it explicitly prohibits superluminal signaling, a restriction that consciousness has not yet been shown to circumvent. Any demonstration of such an effect would not merely require refining existing physics, it would necessitate a paradigm shift equivalent to the revolution brought about by relativity or quantum mechanics itself, requiring the discovery of a previously unknown fundamental force or a radical reinterpretation of spacetime and causality that somehow accommodates instantaneous, purposeful influence without violating the universe's most fiercely guarded speed limit in a way that creates paradoxical timelines. Until rigorous, independently replicable experimental evidence emerges that isolates a conscious influence and definitively demonstrates superluminal causality, the answer, according to the totality of current empirical physics, must remain a resounding no, though the tenacious human mind continues to probe the shadows where the edges of the known universe meet the mysteries of the inner self. The continuous quest, however, drives innovation in measurement, in theoretical modeling, and ultimately, in our understanding of what it means to observe, to exist, and to interact within the grand, constrained theater of spacetime.